Hi, I'm Ian Wells, and I'm going to be talking about a few of the scraping projects I've been working on over the past few weeks. Timelineo. Timelineo is an AI-generated musician and artist front-end timeline. The application displays chronological, relevant dates, facts, and associated images from randomly selected best-selling artists. Images and information are sourced from Wikipedia and powered by Reworked AI's powerful web scraper, Harambe. Facts are generated using OpenAI's GPT-4. Timelineo aims to provide history, context, and a more personal connection to your favorite artists. If you want to learn more about musicians and bands, Timelineo might be the app for you. On a high level, our focus in understanding this project will be on the scraping portions of the code design. To the left, we have the actual Wikipedia web page, which our listing scraper operates on. It collects 121 Wikipedia URLs associated with the best-selling artists of all time. To the right are some web page examples of where our detail scrapers are in use. For each page, all image URLs are located with anchor tags within the main content. These URLs are then stored into a JSON and used later for our timeline. Here on the left, we see the actual listing and detail scripts that were used, and on the right, we see the 15,000 line JSON output that is saved. And of course, an overview of the stack that enables this application, reworks Harambe, saves scraped information locally. Python, Fast API, and Docker are used in conjunction to create an API GET request call that Next.js and ShadCN use to display to a pretty front end. Next up, LearnArt. LearnArt is another generative AI application which leverages Reworked AI's Harambe software development kit. LearnArt displays renowned artwork sourced from museums around the world. The app uses AI to generate an artist's biography and provides context to painters, photographers, and sculptors. The aim is to help educate the general public about these works and encourage individuals to visit the museums where these pieces are stored. The app is fully deployed, and you can view it at huggingface.co/spaces/iansewells/learnart. All right, let's take a look under the hood and figure out how this all works. Again, our focus will be on the design of the web scrapers powering our application. Currently, we use a listing scraper to collect 770 URLs associated to the artists in the New York City Guggenheim Museum. On the right, we see the example detail scraping page of Vasily Kandinsky. As our detail scraper paginates, each image is stored by Harambe. Biographical information is collected before pagination begins. If you want to understand how the detail scraper, pagination, and listing scraper function, don't be shy, pause here and take a look at the code. And just a note here, this code was written as I was learning to scrape. If I were to optimize this project, I would definitely go back and consolidate some of the code. Here is the output JSON that we see. So it's the artist, metadata, and their collection of works that we're storing. This is then displayed on our front end. Our database is stored by Amazon's RDS and utilizes MySQL. AWS Lambda helps host our Fast API and Docker GET endpoint on the internet. And for ease of deployment, I kept it simple, running with a Streamlit Python script hosted on a Hugging Face space. Now for some honorable scraping project mentions. Runner-up number 1, a scraper which collects information from capitaltrades.com, a website tracking politicians' stock market trades. Our scraper saves information regarding the stock, politician, action, price, reporting, and trade dates. I also built a scraper which paginates the most recent articles posted on Y Combinator, saving their HTML information to a JSON file. So what did I learn? Where can I improve? If I were to continue with Timelineo, it would be great to deploy the product with AWS and MySQL. I can also optimize OpenAI queries to lower the cost, provide more interesting information, and link to more relevant images. I'd also like to include live performance links on YouTube and productionize using Next.js. For LearnArt, it would be awesome to scrape more museums and scale this project. Again, I can optimize queries for efficiency and cost. And it would also be nice to add a painting feature where people can actually doodle in a way that is similar to these artists. People usually remember more information when they can interact. Plus, I could always revamp the front end. From scraping in general, I learned that it's important to design resistant scrapers which can handle web page changes that potentially occur. It's important to assess pagination from the get-go and perhaps develop some dynamic adjustment of the wait time that occurs when a new web page is opened. As far as best practices go, don't forget to handle potential errors. We want to minimize the chances of scraping jobs being interrupted. Wait for the CSS to appear on a web page before you use a locator, and it might be helpful to use goto to go to a URL before any scraping occurs. Thank you so much for listening. These projects were really fun to work on. I feel like I learned so much about web scraping and designing full stack applications.